Good day, everyone, and welcome to today's Autopath webinar. My name is Petra Tihola, and I am honored to be your host for this webinar, along with my colleague Antonio. In this webinar, we will be exploring practical examples of how to use Autopath efficiently. As you already know, Autopath is a professional software solution for vehicles web path analysis that has become an essential tool for civil engineers, transportation professionals, architects, and urban planners. It enables you to simulate and analyze complex vehicle maneuvers, generate accurate 3D vehicle animations, and more. Whether you are an advanced user or just getting started, we believe you will find valuable insights and tips that can help you streamline your workflows and achieve your project goals with greater ease and precision. I would also like to inform you that this webinar will be recorded, and a recording will be available for all participants after the webinar. So if you miss something or want to rewatch the webinar later, you can easily do so. Throughout the webinar, you can send us questions through the dedicated section in the webinar dashboard. So if you have any doubts or want to clarify something, please type your question there and we will try to answer them at the end of the webinar. Now, we would like to ask you about your background in using swap path analysis software. Especially, we would like to ask which software you use to perform swap path analysis. Please choose one of the answers that appear on the screen. You can also expect another poll at the last part of this webinar. Actually, that one will be bringing a special bounty, so make sure you don't miss it out. Okay, here are the results. As we can see, many of you are already using Autopath, and thank you for sharing your opinion. Let me now introduce our technical specialist, Antonio, who will be taking over from here. With his years of experience in CAD and BIM, he has mastered his field of civil engineering. As a key player in the development of software solutions for roadway design, Antonio has extensive knowledge of the products Autopath and AutoSign, both of which are included in the Platea traffic collection. Antonio is not just a technical specialist, but also a passionate professional who enjoys sharing his knowledge and insight with others. So get ready to be amazed by Antonio's presentation as he takes us through the practical examples of using Autopath software. So Antonio, the stage is yours.
Hi, Petra. Yeah, here Antonio speaking. Thank you for this stunning introduction. So, good day to everybody, and welcome to what is the main core of this presentation of this webinar today. Okay, so we are going to talk about. We're going to explain a few cases about how to use in an easy way the vehicle swept path analysis. Okay. And before we go into the details, into the core of the webinar, I would like just to explain or to mention some historical data that it might be interesting for you. It all connected to the methodology that we are checking today, now this swept path analysis. And the point is that everything started with a man named Rudolf Ackermann. Okay, here we have the guy. This guy started to hear about a system which consisted of a geometric arrangement of linkages, okay, in the steering of a carriage. So we are talking in the beginning of the 19th century for you to to get localized. So the idea wasn't her, it wasn't his actually, but it was this guy Ackerman who patented the system, and therefore the principle was given the name of Ackerman steering geometry. And basically this is the base of the principle that was afterwards developed in order to produce and to implement the swept path analysis as we know it nowadays. So the swept path analysis is the calculation of the movement of the different parts of the vehicles when this vehicle is undertaking a turn. At a basic level, this includes calculating the path taken by each of the wheels of this vehicle, as well as calculating the space needed by the vehicle body during the turn. So what it creates is a envelope, that envelope that covers all the space that is covered by the body of the vehicle. Okay, so after years, we come to nowadays, we have come to the situation where the analysis can be calculated and drawn by software solution, what is a great achievement because especially if you look at it from the point of view of the productivity and accuracy. So these were just a few historical drops for getting warm. Let's now overview what we're gonna do in this webinar. Okay, so the how we are going to proceed. And what we are going to do is to expose 3 cases. One case related to the civil engineering field, one case related to the architecture field, and one more for the transportation planning field. Okay, so we're going to present examples, cases, and we are going to apply the swept path analysis in the easiest way possible. So let's jump into our first topic. So the case for the civil engineering, it's true that here we're going to focus a bit more on the road design. Okay, so this is for it's a case of road designers. We have a roundabout. We're going to have a roundabout, a new design, and where we have drawn a set of polylines. Okay, these polylines are going to, okay, they represent the center line of the different lanes. And what we want to do is to evaluate whether one of our vehicles could go easily through that trajectory that was already planned. So let's move to our CAD platform. Okay, here we have the roundabout. The first thing we are going to do is to choose a vehicle. No. For this case, it's quite useful always to go to these national road designers standards, where actually they show vehicles that are based not on manufacturer specification, but on standards for that needs to be fulfilled on road designs. So in this case, we are gonna use a coach. It's based on the Freight Transportation Association standard, the FTA, and we are gonna use this vehicle to create the swept path, as you can see, on the top of our polyline. Okay, so we create this vehicle, the vehicle swept path analysis on the top of this trajectory. And here we can see, okay, we might have interferences with this curve or this pavement, but okay, but another thing that we need to calculate and we need to actually generate is to check whether the trajectory that we planned is feasible for the vehicle. And this is a report where it shows us the different turning radius for each of the vehicle at each point. We will comment this a bit later, more in detail. And now let me go to do the same thing with a different path. Okay, so we are gonna create a new swept path, you see, in this polyline. Here, okay, again, we can check the surroundings. Actually, we can do that exercise, like dynamically modify the trajectory in order to find the best way or the trajectory that better suits this vehicle, no? But as I said, it's very important once we go with this method to check whether the trajectory, the polyline that we had as default, fulfill the requirements of the vehicles, because we can draw any polyline that vehicle will go through. The program will give us the solution, but then we can come to the point that maybe the minimum turning radius of the vehicle doesn't fulfill the condition. Okay, and for this is this graph. It's explicitly in a very explicit way. It shows this behavior of the vehicle. Okay, we are not talking only about motorized vehicles now in this part. We can also go and check some other, like for example, we have on the upper part of the drawing some bicycle path. So we can perfectly also evaluate the trajectory and the path of this of this part of the network for this bicycle. So here we are. We have created also the swept path analysis for the bicycle. One last tool that might be very interesting for when checking and verifying the different aspects of the new roads is to create or to use a kind of old school concept, which is the turning templates. Okay, what these turning templates, I'm creating here. Okay, I'm selecting the direction, and they are created. These turning templates help us to evaluate a simple turn. We are not evaluating the whole path, a complex path, but just a simple turn for certain situations where we just need to check a quick verification now. So this might be very interesting and useful for the road designers. And okay, so this is all what I wanted to. Okay, of course there are many more polylines and trajectory could be drawn on this roundabout in order to evaluate it in a more complete way, but this was an example, and I would just like to come up with the points, with the key tools that we talked about, right? First of all, I would like to recall that the vehicles that we used were based on national road design standards, so they are worldwide standards. Some of them are worldwide, some other are nationals based on the country, to evaluate the behavior of the vehicle on the road design. For that, we created polylines that represented the trajectory of the vehicles, and on the top, the swept path analysis was created on one click. What we said that, okay, it's definitely a good method, but we need to be careful with checking the feasibility of this polyline. So they might not always fulfill the condition of the turning of the wheels of our vehicle. So for that, we had that graph where we could check easily how which was the angle turning of the wheels at each point of the path. And the very last part was this vehicle turning templates, which help us to quickly, in just a click, create and see the movement and the path that this vehicle would take for different angles. This is about this first case. Let's jump to next case, which is architecture. So the architecture is a field that aim the design of spaces and environments. So for people, right, mainly. But we must not forget that we have vehicles also in our lives. And here is where we come with our next case, where we are going to present, it's gonna be an underground garage, okay? Underground garage that it would be even harder to design if that garage will be projected on a refurbished building. No, so let's take a look at the situation. Here we have our garage. We already started to create some swept path. Here we have the slope, and what we are going to do is to recreate the movement of the vehicle backwards. And this time we are not using any more polylines. What we are going to use is just the program is gonna let us drive the vehicle backwards. Okay. So for that we are gonna select different points. Each point is going to be it's gonna become a point of the path, and in this way we can see the movement that the vehicle is gonna carry out. So we are drawing ourselves the path, and the program is generating the swept path. Another interesting thing here for architects is like, okay, we are facing with a lot of constraints, right? Boundary constraints. So it would be very nice to have a tool that point out, that highlight those elements that might interfere with our swept path, with our vehicles. And here is another tool where in 2 clicks we can achieve that. Okay, so now we know the problems where we are going to have the problems. And another thing that I wanted to show you, especially for architects, because I know that they're really focused always on the aesthetics. And this is a nice way of presenting to a client why we chose that solution. Now, this is what we are doing is running the animation. So we are recreating the movement of the vehicle. At this point, okay, we can even set some prints so we know the situation of the vehicle, especially at the critical points, and we can have that show that and have that in mind for later, in order to change our designs or make the fixes that are necessary. But okay, well, another big constraint, big challenge when designing underground garages is the vertical gap, the height of this entrance. And for that, we're gonna run again the vertical analysis, and this time we're gonna see the swept path in a different view, okay, in the vertical view, the profile of the vehicle. For that, we can run again in order to make sure that we see all the conflicts are highlighted, this collision detection. But what I wanted to say here, this point is like, okay, this is what we are doing. It's might make sense for to check or verify the path of the vehicles after the design, but also before, also when we are at that stage of conceptual design, you see we can dynamically change the different options, different geometries. Our path will be updated, and in this way it's a really easy way to verify and to check different options. Of course, there is always need to be a gap between the ceiling and the upper part and the vehicle, so we can create an offset to make sure that that space is going to be free of obstacles. And once again, let's do the animation. So let's run the animation and let's make some prints of the vehicle also in this vertical, in this profile view, right? So if you let me wrap up everything what we said up to now, in this part, in this case, in the architecture case, we used a different method to create the swept path analysis. In this way, we didn't use predefined polylines. We went directly to draw ourselves the vehicle. So using interactive method, which is named Easy Drive. Okay. Another thing that maybe didn't manage to show, but we will see later, is that this vehicle was not anymore a conceptual vehicle. It was a model, a brand model vehicle. So I think it was a Mercedes, some model of Mercedes. So there are also possibility to use this kind of real vehicles. Then we checked collision detection. We checked those elements around the swept path analysis and pointed out those ones which had some kind of interference. And once we moved to the vertical analysis, we created a clearance, an offset around the vehicle to make sure that that gap is going to be free from obstacles. And in both views, we managed to create an animation to recreate the movement of the vehicle, and even to make and to put the vehicle at those points of the path where the problems might appear, right? So we are aware of the whole situation. This was everything about the architecture case. Let's now jump to the last but not least, the transportation planning field. And this part is dedicated for those professionals who mainly work with the transportation of goods, or even with special loads, right? It's always tricky to plan an effective route for heavy vehicles and some other as cranes, for example, no? So, and especially I know that in urban areas and narrow inter-urban roads might be the hardest. So our case, we are going to start planning. We're gonna start actually moving to using a tool that it might be really interesting for this case, for the others as well, but this one especially. So because here we are always dealing with the real world. So it's really interesting to have always an interface with the real world, and being able to bring that data, not only the image but also the elevation data, to our CAD platform. Now, I think that's really interesting for this type of professionals. Afterwards, we can draw the city on the top, or we can just work directly with the map. And here is what I mentioned before. Okay, let's take an overview over the different vehicles based on manufacturer specification, on supplier specification. As I said, we might use cranes, trucks, big heavy trucks with trailers, wheel loader. In this case, we are going to use a Goldhofer truck with a trailer, and what we are going to use this interactive method to create accurately the path of this vehicle. Now it's a city. We are playing in a city. it's always hard to check the maneuvering of this vehicle in certain situations, especially in urban situations. So here we are choosing each point of our path. We can see the prediction of the turning prediction, sorry, of this vehicle. So giving a point, I can know where this vehicle is gonna move, the possibilities of this vehicle for movement in the future. Okay, once we select our set of points, we can generate. The program will generate will make the calculation and generate this swept path. It's really easy. But okay, this is our trailer in this point is unloaded. What if we want to load the vehicle? No, so for that we can create a customized vehicle and draw and change actually the geometry, making the geometry that also take into account the shape of the load. Also, we can change some other specifications and other distances and parameters in order to create a new vehicle that take into account our load. And what we're going to do, it's what if we create the swept path of this loaded vehicle overlapped on the previous one. So this is exactly what we have done at the moment. Here we can evaluate the problems that our load will give us. No, so it's because it's not the same evaluating the empty trailer than with the load. But imagine that it's quite tedious to create a new vehicle for every customized load that we have. So another way that we can do that, it's not actually evaluating the whole swept path analysis of the load, is to insert or even to draw the shape of the load over our trailer. This is what we are going to do. This is what we are doing. I'm just drawing with a polyline the shape of a customized load. In this way, we can evaluate the movement of certain points, those which we are going to call the critical points of the load. Now, this one is going to be one, and here on the other side is going to be the second one. So we're going to have this purple path that represent the movement that these points are going to take. Yeah, so much quicker. And just for the last thing I would like to show, it's something that we didn't, so far we have been working on 2D. Let's jump to another easy command to create the 3D model of our vehicle. So this definitely gives us the opportunity to create and to see the movement in 3D. It always helps us to have a better perception of the surroundings. And here is where we are now. That's what we created is the same animation as we did before, but in 3D. So we have a 3D solid, which is our vehicle, and we can still make prints and so on for later, for further evaluations. And the point, another advantage here is that, as we drawn before the load on the top view of the vehicle, we could modify the 3 views of the vehicle by just in 2D by using polylines. And once we get those 3 views of the vehicle, the horizontal view, the vertical view, and the front view, what the program is going to do is it's going to be able to generate automatically a 3D model. So no tedious modeling of 3D vehicles anymore. Just gives draft the 3D views, the 3 views, and the 3D model will be generated. So this is an overview of our city with our track here. And okay, let's point out what we saw in this case, right? Here we used again the interactive method. So if you recall it, it was we were choosing the points of the path. We were driving actually our vehicle with the help of the program, which was showing us the prediction of the turning, right? At the very beginning, we used this Google Maps import to be aware and to import the data from Google Maps, be aware of the real situation. We didn't use it here, but it's also possible to export the swept path analysis, our elements, to the Google Earth, okay, for better visualization as well. After that, we were playing with this truck, with this trailer. We make a custom vehicle. It was easy. We just needed to modify the geometry and some parameters of the axles. In our case, we didn't, because we were just taking into account a customized load. So it's also possible to adjust loads to the vehicles. But as we said, sometimes creating a new vehicle for a new load is so tedious. So we can just create the load, place the load on the top of the vehicle, and just track the points. Let's say create the path that those critical points are going to take through our trajectory. And at the very last, we went through the 3D animation. We saw, we recreated the movements of our vehicle in 3D. And so we had a better perception. It's even better for showing to the client and have actually 3D solids as the vehicle in shape of 3D solids. So I just want to here just about to finish. I'm gonna bring all what we have learned, or everything what we have used through these 3 cases to this screen, and just to mention that indeed the product that I used was Autopath. That all this functionality that for each of them didn't need more than 2 clicks. It's gathered. It's part of Autopath. And now I would ask Petra. Petra, could you tell us a bit more about Autopath?
Yeah, sure, Antonio. I'm happy to provide some additional information about the Autopath program. And yeah, Antonio, thank you for sharing these amazing practical examples. As you saw, Autopath is an incredible flexible software that has applications across a wide range of industries. As you've seen, it's a valuable tool for civil engineers and architects, but it is also used in intralogistics to simulate the movement of goods through factory lines. In addition to these applications, Autopath can be used to simulate aircraft maneuvers, which is critical for designing efficient and safe airport infrastructure. This is a prime example of how technology can be used to improve the safety and functionality to critical infrastructure. The possibilities with Autopath are truly endless. And one of the most incredible advantages of Autopath is a huge library of country-specific reference vehicle libraries defined by national guidelines, an extended collection of real vehicles covering aircrafts, buses, trucks, trailers for wind turbine transport, cranes, emergency vehicles, and more. So by scanning this QR code, you can find a list of all vehicles in the Autopath. But it is not all. If you require additional vehicle beyond what's already in the library, our technical team can create custom collections to meet your specific needs. This is another proof that Autopath's level of flexibility and customization is what sets it apart from other software programs in the market. The proof that CGS Labs takes customer satisfaction seriously is that we offer live technical support. So our support engineers are not only highly experienced, but are also certified civil engineers who can handle any problem, no matter the complexity. Additionally, we offer many free courses. On our website, you can find CGS Labs Academy, where we provide you with free basic training. For each course, you will find a video tutorials, PDF instructions, and DWG drawings to help you practice the procedures. You can also subscribe to our channel, YouTube channel, a blog and LinkedIn profile. And on the Go to Stage channel, you can watch all old webinars for free. And I would also kindly remind you that we uploaded a handout with very useful information about Autopath in the system in this Go to Stage webinar, and you can find it in a handout section. If you want to make sure that Autopath is is really the right program for you, you can download the free version today. With our free trial, you will have full access to all the features and functionalities of the program. And if you have any questions or need support, you can also contact Antonio and he will be happy to answer any question you may have. At the end, I would like to briefly say something about CGS Labs. CGS Labs is a company with more than 30 years of experience developing software solutions in the field of transport infrastructure and also the environment. Our software solutions are Platea, Ferrovia, Aquaterra, AutoSign, and Autopath. Platea is used for road planning and reconstruction, Ferrovia for railway designing, and Aquaterra for channel and river engineering design. And AutoSign is a software for planning traffic signal design. All our software solutions run on top of Autodesk AutoCAD, Autodesk Civil 3D, or BricsCAD, and they are compatible with several of the latest versions of Autodesk platforms, as well as the three latest versions of BricsCAD platforms in general. And as a development company, we are also on the forefront of industry standards and best practices. We are involved in the development of BIM, building smart activities, and contribute to the development of standards in the field of digital infrastructure design. So by choosing Autopath or any of our other programs, you are not just getting a powerful and flexible tool for infrastructure design, but you are also getting access to the latest knowledge. Now, at this point, I would like to check the questions. I saw that there are three questions. So, Antonio, can you answer the first one? The first one is, what is the relation between the vehicle speed and its corresponding swept path analysis?
Yeah, Petra, of course.
Okay, thanks.
Well, I must say that this vehicle speed, when we carry out swept path analysis, usually swept path analysis are used for those critical maneuverings, and always, or most of the times, these critical maneuverings are always undertaken at the lowest speed. So here, when we create a swept path analysis, we don't take actually we are always playing with the minimum radius. Okay, so we are supposing that even at the lowest speed, the vehicle is gonna make it, right? Yeah, I think there is some. It's true that we have some other settings like vehicle speed, the animation, but that's only the speed with the vehicle is just moving and creating the animation. It's not for the swept path itself. We should always suppose that even at the lowest speed, the vehicle is gonna make it. We are gonna represent that path at the lowest speed. I think it's
Okay.
I think
Okay,
this
then we
answered a
can.
bit.
Yeah, thanks. Then we can move to another. So the second question is instead of choosing a single trajectory or a polyline, it is possible to choose the lane width and let the software choose the optimal path.
Well, that's a very interesting functionality. At the moment, it's not possible to do that, but definitely it will be very interesting to develop for the future. So, yeah, thanks for the tip.
Okay. The next one is this tool available in Civil 3D in the country kit?
Well, I think it's worth to mention that we are not. This is a separate product. It's true that it works on the top of Civil 3D, but it doesn't. It's not connected at all with the country kits. It's a CGS Labs product. Yeah, it's just that work on the top of Civil 3D and other cuts. But it's CGS Labs product, so you need to contact us to make it available for you.
Okay, and yeah, as we mentioned before, we also the customer can also download the trial to test it. Okay, then the question is how to create a vehicle and add into the library. And this is a
Well,
little bit
I think,
complex maybe for today.
yeah, I think we showed something in the previous cases. We can send to this user a set of. We can connect to him later afterwards, or send some videos that will help him definitely.
Okay. Then, when using horizontal analysis, how to change speed of the vehicle?
Yeah, this is the same. This is very much connected to the previous question. No, the speed. When we are generating a horizontal analysis, we always suppose that the speed of the vehicle is gonna be the lowest. Okay, so even at the lowest speed, the vehicle is gonna make it. It's gonna be able to make the turn. It's just by definition of what the swept path analysis is.
Okay, thanks. Then is a question. Sorry. Can we change the vehicle dynamics, such as steering angle and other parameters?
Yeah, of course, we can. You can create a new vehicle based on an existing vehicle. You create a customized vehicle, and there you can modify the different parameters,
Okay.
geometry and radius. Yeah.
Yes, it has many different options, as we already saw in those videos. Then the next question is, do we have Indian standards vehicle for analysis?
Yeah, I think we have some based on the national road designs, right? We can send to this user more information about the Indian
Okay.
standards.
Yeah, so after the webinar, we will send those customers emails with additional tutorials and information. Then we have 4 more questions. Okay. Can we change the number of the axles or the size of the trailer tractor in the transportation part for special transportation?
Of course, yeah, this is totally available. At the end of the day, what Autopath is going to to offer is a lot of flexibility, right? So, okay, we have a list of predefined vehicles, but you are free to take one of those vehicles and change geometries, distance between axles, distance between the wheels, any parameters that regard this aspect. It's free to be changed and be adjusted to you.
Okay. And there is one more question about Civil 3D. So, Antonio, can you explain more in detail what's the difference or what is the relation between the Autopath and Civil 3D, or the Autopath and AutoCAD and or BricsCAD?
Yes, of course. Well, let's say Autopath, it's a application that works on the top of Civil 3D, AutoCAD, and BricsCAD. Okay, that doesn't mean that is connected or that the manufacturer is the same as Civil 3D, BricsCAD, or AutoCAD. We have CAD platforms which are developed by and they are worldwide known. And then we have Autopath, which is an application that works on the top of this. And this application that works on the top of Civil 3D, BricsCAD, and AutoCAD is what we were presenting today, Autopath. And this is a product developed by CGS Labs.
Okay,
I hope
thanks.
I was clear now.
Yeah, there are a few more questions about those tutorials for learning how to add new or new vehicle to the library. So after the webinar, we will contact you and we will send you more information and tutorials. So thank you for all those questions. And I think there is the last question is, can we simulate oversized transport to find out the maximum dimensions that can pass through a section?
Yeah, of course, we can simulate we can simulate any type of vehicle or transport. Okay, once we create that vehicle or that oversized transport, there are different tools as we saw. Like for example, the collision detection would be a very interesting tool to be used in this situation now, because you have like different elements that represent the edges of your lane, and with this tool, creating the swept path analysis and using the collision detection will highlight and therefore will show you which is the maximum dimension for your vehicle to be able to go through that section.
Okay, we got one more question, and this is how we can update the geometrical parameters of the vehicle, means axle turning radius or axle space speed.
Well, all that is in the I think we showed before that dialogue. This is a more complex answer, or more complex procedure to show. So I think we can address this user directly and share with him some further information.
Okay.
Just make him show him the available videos.
Okay, thank you, Antonia, and thank you all for all your questions. So I would like to now run a quick poll because in the first poll we saw that some of you are not use the Autopath program yet. So my question is, are you considering to invest in a software for swept path analysis? And as a special offer for those attending this webinar today, we are also providing a discount on the purchase of the Autopath program. So don't miss this opportunity to enhance your infrastructure and design capabilities with our powerful and flexible software solution. So, thank you for joining us today and taking the time to learn more about Autopath and our other software solutions. We hope you'll find the webinar helpful in your work. Remember, our team is always available to answer any question you may have to, or provide support with our software. Again, thank you for attending, and we look forward to seeing you at our next webinar, where we will continue to share our knowledge to help you streamline your infrastructure design procedures. Have a great day and goodbye.